Hello and welcome to part 2 of this exam series where we'll be looking at the GCSE Maths exam paper from AQA for June 2018, paper 2. We're up to question number 13. Let's begin. Question 13. Here is a formula for the amount of water needed to cook rice. W equals 1.5 R plus 0.5, where W is the number of cups of water needed and R is the number of cups of rice to be cooked. Part A. How many cups of water are needed to cook 7 cups of rice? So the value of R, the number of cups of rice, is going to be 7. So W is going to be equal to 1.5 multiplied by the number of cups of rice, which is 7, and then add 0.5. 1.5 times 7 is 10.5, and then when we add 0.5 onto that, we can say that we need 11 cups of water to cook 7 cups of rice. Part B. How many cups of rice can be cooked with 20 cups of water? So this time the value of water, the W, is 20, and that's equal to 1.5 R plus 0.5. Now this time we're trying to work out the value of R, which means we've got an equation to solve. So this value of R, some number multiplied by 1.5 and then adding 0.5 will give us 20. So before we added that 0.5, if we subtract that from the 20, that 1.5R would have to be 19.5. 19.5 plus 0.5 gives us the 20. Now that 19.5 is the answer you get when you take the number of cups of rice and multiply it by 1.5. So if we undo that and say that the number of cups of rice that is needed, if we take the 19.5, we can divide that by 1.5 to say that for 20 cups of water we can cook 13 cups of rice. Question 14. Use your calculator to work out 9.95 squared multiplied by 29.8. Give your answer as a decimal. Write down your full calculator display. So this is the question where you need to use your calculator effectively to work this out. You can do the two individual items separately and then multiply them together. If you're confident, you can put it all in at once. I'm just going to give you the answer to this one. So 9.95 squared times 29.8 is 2,950.2745. Part B. Is your answer to part A sensible? Use approximations to decide. You must show your working. Approximations is the other way of saying estimation, which means that we are going to take each of the numbers in the original question and round them. Traditionally this is to one significant figure, but we're trying to make the calculation as easy as possible to do. So 9.95, when we round that, will become 10 squared. So instead of 9.95 squared, we do 10 squared. 29.8 is very close to the number 30. So our approximation of that calculation is 10 squared times 30. 10 squared is 100, times by 30 is 3,000. Is that a sensible approximation? Well, 2,950.2745 is very close to the number 3,000, so our answer is sensible. Question 15. The graph of y equals 4 minus x for the values of x from minus 2 to 5 is shown on the grid. Part A. On the grid, draw the graph of y equals 2x minus 5 for values of x from minus 2 to 5. So we're going to need to work out coordinates in order to draw that line. So I'm going to draw a table for us to fill in. The table is going to include x and y values. And to start off with the values of x, we are told need to go from -2 all the way up to 5. To work out the y values, we're going to take each one of these numbers in turn and place it inside that equation, substitute them in, work it out, and then find out what y becomes. So we're going to take each of those values of x, we're going to multiply them by 2, which gives us the 2x, and then we're going to subtract 5. So we're multiplying by 2, then subtracting 5. So from our table, -2 times 2 is -4, and then when we do -4 minus 5, we get -9. 2 times -1 is -2, and -2 minus 5 gives us -7. 2 times 0 is 0, -5 is -5. 2 times 1 is 2, -5 gives us -3. 2 times 2 is 4, -5 gives us -1. 2 times 3 is 6, -5 is 1. 2 times 4 is 8, -5 is 3. And 2 times 5 is 10, -5 is 5. We only really need at least 3 of these points to draw a line, 2 of them to draw the line itself, and at least 1 more to make sure it still lies on that line, but I've done them all anyway. These are now points that we can plot on the graph to draw our line. So -2 minus 9 is there, -1 minus 7 is there, 0 minus 5, 1 minus 3, 2 minus 1, 3, 1, 4, 3, and 5, 5. These points can then be drawn together with a straight line, and that is the graph of y equals 2x minus 5. Part B. Use your graph to solve 2x minus 5 equals 4 minus x. Now each of these parts of this equation is what these lines end with. We've got the 4 minus x and the 2x minus 5, which means that we're just using the graphs to work out this answer. So we're trying to find out when these are equal to each other, which means that's the point where they cross, where they match. You can see that that point is this one here. And we want the x value when that happens. So the x value when they cross is the number 3. Question 16. BCD is a straight line. Triangle ABC is equilateral, and CE equals DE. Work out the size of angle X. Okay, I'm going to start with the isosceles triangle on the right hand side. We've got an angle of 28 degrees, and we've got 2 lines that are equal. In an isosceles triangle, the base angles, which means that these 2 angles at the bottom, are equal to each other. Now, we're going to use the fact that angles in a triangle add up to 180. So if we already know that one angle is 28, we can do 180, subtract that 28 to give 152. So 152 degrees is the total of these 2 angles, and since we know that they are equal because it's an isosceles triangle, you can do 152 divided by 2 to get each angle being worth 76 degrees. On the other side, we are told that triangle ABC is equilateral. If this is an equilateral triangle, then that means that all three of these angles are going to be the same, because all three of those sides are the same. So using the same fact, all the angles must add up to give 180 when inside a triangle, so we can split that 180 equally between the three angles to say that each one of them must be just 60 degrees. So each of them are 60 degrees. Finally, we're going to use the fact that BCD is a straight line, and the statement angles on a straight line add up to 180 can sometimes be confusing, because BCD, people often see all five of these angles, but they can't possibly add up to 180. What you are looking for is something that forms almost looks like a semicircle. They're the angles that add up to 180, so it's those three that are around the point C. So the 60, the 76 and the X will add up to 180. So the 60 and the 76, when we put them together, it gives 136. And when we then subtract that 136 from 180, we'll say that angle X must be 44 degrees. So X is 44 degrees. Question 16b. Amber is working out the size of an interior angle of a regular octagon. Her method is interior angle equals 360 divided by 8. Is her method correct? Now, an interior angle is an angle on the inside of a shape. These are normally found by splitting a shape into triangles that are each worth 180 and then working out an individual angle. From her method, she's done 360 divided by 8. Now, the 360 is not the interior angle sum. That only works for quadrilaterals. What she's actually thinking of is an exterior angle. Here is an exterior angle. That is always found by doing 360 divided by 8. So her method is not correct, and the reason is that it would find the exterior angles. In order to find the interior angle, she would need to do 360 divided by 8 to work out this. So 360 divided by 8 is 45. And then we would do 180 minus that 45 to work out that angle. Question 17. Here is a map of an island with cities A, B and C. The straight lines represent roads. So on our map we've got a scale of 1 centimetre representing 200 kilometres, and we know the direction of north. Part A. A is due west of B. Write down the bearing of A from B. Now, a bearing is an angle measured from north clockwise to show you the direction from one place to another. Now, normally when you're working out angles or you're measuring them, you use a protractor. We don't need that in this case because we're told that A is due west of B. Just to show this, if we've got a compass point, we know that we've got north, east, south and west. And if something is due west, that means we're trying to work out the size of that angle there. So going from north, measured clockwise until we're pointing at that line, which you can see this angle here is 90 degrees, which means we've stopped 90 degrees short of 360. So we can do 360 and minus that last 90 degrees to get an answer of 270 degrees. We could also have added together these other three right angles. 90 times 3, or 90 plus 90 plus 90, will also give you that same answer of 270 degrees. Part B. Umar drives from A to B on the route shown. Kaz drives from B to C on the route shown. Use the map to work out how much further Umar drives than Kaz. You must show your working. So we're going to need to measure these lines because it's drawn accurately to scale, and then we need to scale it up from the map to the real life measurements. So starting with the measurements, to go from A to B we would measure with a ruler. That's 6.5 centimeters. To go from B to C, we've got two separate lines to measure. So from B to that junction is 2.7 centimeters. And from that junction all the way to C is 2 centimeters. So let's work out our distances. So from A to B we've got 6.5 centimeters, and the total distance from B to C will be the 2.7 plus the 2, which is 4.7. We can now use our scale. On the scale we say that 1 centimetre represents 200 kilometres, so for every 1 centimetre it's 200 kilometres in real life. So if we've got 6.5 centimetres and 4.7 centimetres, we can multiply both of those numbers by 200 to work out their real life counterparts in kilometres. 6.5 times 200 is 1,300, so that's representing 1,300 kilometres. And 4.7 times 200 is 940 kilometres. If we need to work out how much further Umar drives than Kaz, that means we want to work out how much bigger 1,300 is than 940, and we can do that by subtracting them. So 1,300 minus 940 means that Umar will drive 360 kilometres further than Kaz. And question 18 will be the last question in this part. A shop sells raincoats and umbrellas. The scatter graph shows the monthly sales for 12 months. Part A. Write down the type of correlation shown by the graph. The correlation is the link between the two different parts of the information. So it's the link between the sales of raincoats and the link between the sales of umbrellas. So from the graph you can see each of these points are trending upwards, going from left to right, which means we call that a positive correlation. If they were trailing downwards in this direction, it would be called negative. Part B. The manager expects the sales of umbrellas next month to be £60. Draw a line of best fit to estimate the sales of raincoats next month. So we need to use a line on this graph to use this estimate. Now a line of best fit needs to do two things. It needs to go in as close a direction as these points as possible, while trying to maintain roughly the same number of points on each side. So these points need to be going roughly upwards, and we need to try and balance them somewhere similar to that. Each different line from different people, when they draw it, might be slightly different, which means that they'll be lenient on you for this answer because it all comes down from your line as long as it's close. So they give a range of values. So for this, if we are using £60, we need to draw a line up from 60 for umbrellas until we hit the line, and then we go across and read off our values. Now each of these squares on the scale is going up in fives, which means that if I've landed one square above 125, my answer is going to be £130. But yours might be slightly different. It should still be correct as long as you've drawn a correct line of best fit that's roughly equal on each side and going in the rough directions, but it can be different. Right, that's the end of this part. Join me for part 3 where we'll finish the rest of this paper for question 19 onwards.